Okay. Hello. Uh, I hope you are staying safe. So I'm in South Korea right now. I traveled back to my home country. I think the South Korea the situation in here is better. So we we have the elections yesterday, no, 2 days before, whatever. And so yeah, we are doing better here. Okay, so today's lab, we will talk about interaction and F-test. So let's go. Okay, for the business, uh, there is a two remain the due dates. Like first one is about classmate feedback, and second one is about final paper. So do not forget about to give your classmate the feedback, and the feedback due is April 27th, and you need to forwarding me or Costanza, the TAs. So when you give your classmates the feedback, please um, forwarding us. And the final paper, the due is April 1st. So uh, yeah, we are almost done, and I believe all students are doing great. So we can do it. And then, so uh, one thing that I want to talk about is about the office hours. So uh, I am doing office hours in Monday and Wednesday in the morning, but uh, stu students are were not did not come my office hour as much as I did in not the internet before. So please come my office hour and bothering me, that then I can help you to write your final paper. Okay. About the I want to say a little about the rough draft. I finished to give you comments about the rough draft, and uh, if uh, so there are two main things I want to talk about in general. So first one is about the theory part. So most of the students do a good job on building a theory, but uh, but sometimes uh, sometimes the theory part is just about uh, kind of the literature review. So I want to make sure that theory, when you're writing a theory, one there is a two things are important. So first one is about summarizing and introducing uh, what the other scholars said before. This we called about the as a literature review, but it is also important to build your own argument. Some of some of students uh, stop just where the literature review. So some of students not doing pretty well job to explain their own arguments. So please try to build your own argument, uh, not just summarize the other's argument. And the second part is about the method part, the data. So you know we need to run we need to run a regression analysis for this paper. So it is important to have your own data set uh, and download it and download the data set and import the R and run a regression analysis. This is required. So, but I believe uh, some of students uh, still have an issue to have their own data, not completing collecting the data yet. So if you have such kind of an issue right now, please contact me or the other TA, Kostanja, and let us to help you to build your own data. This is important, okay? Okay, so today's lab is about the interaction and conduct the app test. And the next lab will be about how to write a paper. So this is the last lab. We introduced our code, and we will talk about today about some recapping multiple regression, and we will talk about interaction and how to interpret the results and doing the F test. Okay, let's move to our code. Mm-hmm. Okay. Okay, great. Okay. So first of all, we need load ggplot for this week lab. This package is about making the graph more better. With by using this package, you make more pretty and better graph. Okay, and there is another tip about checking your R version and update your R. So when you follow this flag on your own, then if you have some trouble or error message about loading the other packages, then you need to suspect that whether your R version is the most recent one or not. So when uh, if this is the situation, I recommend you using this code, the R version. Then when you run this code, you can find uh, which version you have on your computer. So the most recent version today is 3.6.3. So if your R is not this version, I recommend you update your R. Updating R is you can do it by just, okay, give me a sec. If you want to update the R, then you can do it by Googling download R and go to the first section, and depending on your software, like for me, I using the Windows, I will download this, and if you use Mac, try to find the Mac version and click it and download it. We've done this before, okay. So the other way, another way to update the R is by using code. You can run the code and let the R Studio download the recent version R, and then yeah, like this. So to do that, you need the package which called install. So first insert the package and load the package like this, and use the code which say update R. This is R is would be captured, should be captured. Then, so for me, I have the most recent version. So it the message pop up. I don't need to update R. But uh, if you do not have the most recent version, will come up some downloading and several messages that the options about installing how to install the R. Then you can run this by on your own. After that, go to the after that what we need to do is a setting working directory. So as we've done this before, uh, first find out which working directory which folder is your current working directory, and if the folder is not what you want, then change it by using code of the setwd. Okay, and clear the global environment. Then we are done. This is the preamble that we need to do before doing the lab. Okay, so today I will use the data about the diamonds. We have used this data before. So if you want to use the data about the diamond, then run this code, data and diamond. Then we can see some new data set, data frame has popped up. Then let's see what's going on in there. So this is the data set is about the diamond, and we have 53,000 observations, and we have 10 variables. Each observation is about a diamond, and we have the information about this diamond, about carat, cut, color, clarity, depth, table, price, and XYZ. So today, the information we want to explain is a price. How much the diamond, how much a price, how much a diamond is. Okay, so we want to explain the price of the diamond, and we will use the variable of the carat, cut, and depth to explain the price. Okay. So our independent variable is the main is cut depth, and so if you remind that we have 4 types of data, which is nominal, ordinal, interval, and ratio. And then we can see cut, color, carat, depth, and price has a different types of the data. So first, the color is just the nominal, which means they have a different category, and they are not be ordered, but comparing with the color, cut ha, uh, has a different category, but it can be ordered from fair to ideal, like this. So the cut is ordinary variable, right? And the others, depth, price, and caret, is a continuous, and it can be divided, so it is a ratio. And we can see how each variable are distributed by using qplot, which makes a histogram more concisely. So this is the distribution of the price, and this is the caret. And so we can see the price and caret is skewed and depth, but depth seems like distributed normally with high peak, and cut. So because cut is an ordinary variable, the histogram looks like a bar plot. So in this plot, we can see how many observations are belong to each category, okay? So the fair is the least number, and ideal has the most number. Okay, we have learned about the multiple regression, which is different with the bivariate regression in terms of we include more than one independent variable in the equation. So I want to do multiple regression to account for the variation in the price. So this is, I call it as a model 1, and I want to explain the variation in price by using caret, depth, cut. Okay, run it and summary. So this is the result of the linear regression, and we can see there it is something weird. In that sense, we can see different variable names of the cut, and so this going weird. Why is it? What happens in there? This is because if you see how the cut is coded, we can see they are non-numeric variable, right? And they is coded just as that character, like using the word. So when you conduct regression with a variable that's coded as a non-numeric, then it might face a weird result. So this is important. It is important to recode it, these kind of variables from the character to numeric variable. So I want to create a dummy variable for cut time. Okay. Right now, we have 5 categories of the cut, but let's say I want to have a new variable, which is the dummy variable of a cut. And in the dummy variable, I want to give 0 if cut is fair, and I want to give 1 of all the otherwise cases, okay? All the other cases. So the site package is about uh, this summarizing your data by uh, some category. So if you conduct describe by, then this code will describe the summary statistic of the price by cut. Okay, then we can see we have different groups here from fair, good, very good, premium to ideal, right? And we have different summary statistics about the diamond price. So we can interpret this result as in the group of fair, which means when a diamond cut is a fair, the mean of the price is 4,300, something like that. And then the standard deviation, minimum, maximum, and something like that. And there is a different numbers, like we can compare the price, mean price of the fair to the mean price of the ideal, like this, okay? This is one way to summarize statistics by group. And let's create the domain variable of the cut. So I want to create a two category. First one is about just fair, and second one is about from good to ideal, okay? Then let's say the new variable is as a cut cat, okay? And I will assign the value of the 0 if cut is fair, and I will assign the value of the 1 if all other belongs to all other categories. Then let's generate cut cat inside of the diamond data set, and it would be numeric as a factor. I will give 0 if the cut of an observation has a value of fair, and I will give 1 into cut cat variable if the observation does not match this condition. It's not met. Okay. So when we learn the code, okay, let me explain one more time. So the if else code is about first giving the statement, the condition, and second one is about the is about when this condition is met, I will do the second line, and if not, if this condition is not met, then I will do the third part. Okay, so we can interpret this code as I will create the cut cat variable inside of the diamond data set, and the cut cat will be assigned 0 if we met this condition, but if not, if this condition is not met, then I will assign as 1. So we will see if this code nicely works. We will see that the cut cat will be 0 of the variable of fair cut, and will be 1 of all the otherwise categories. Okay, so run this code and see. As you can see, we create as you can see, we create a new variable which called as a cut right? And the value of the cut is one, either one or zero. And you can see if cut is fair, the cut becomes zero. If not, very good, premium idea. The cut variable is assigned as a one, right? So it works nicely. We can also find out whether it works great by subset. So I will make a subset of the diamond data set. Just pick, extract every observation of which cut variable is a fair, okay? Then let me see. So every cut variable is a fair, right? Okay. And the cut is zero, all of them. So I think so we successfully made the new dummy variable. Then by using the dummy variable cut, I will run the multiple regression again. This model called as a model 2. So in this regression, instead of the just cut, which is ordinary variable, and coded with the characters, I include the cut, which is dummy variable, and coded as a numeric. And then summarize the result. So we can see the result is more become more concise and plausible, and we can interpret this result like so carrot has a positive relationship with price, and when carrot increase as one, the price is estimated as increased by 7,800. Okay, and that has a negative effect on price. And if that increase as one, then the price is estimated as a decrease by 54 or 55. And cut, this is the dummy variable of which we've created, right? So cut could be either 0 or 1. So if in the interpretation of this result, the observation, the diamond, which is coded as 1 in cut, which means the diamond, the cut not fair, better than fair, is estimated as a higher price than fair cut diamond, and the difference of the price is estimated as 1,400. Okay, this is a recap of the multiple regression and using the dummy variable. So when you I want to remind two things. The first one is about when you're using ordinary variable, when you just run the regression with like coded as characteristic, then you will might face something weird results like this. So if that is the case, it is important to change the ordinary variable to as a dummy variable or numeric variable, right? So when you do that, you can see more clear and concise results. Then I I will introduce some graph and how to I will introduce how to interpret the graph and introduce the interaction term. Okay. So for making, I want to introduce a new code which calls a plot model. This code is great, do great job in plotting the regression model. So if you want to use this code, please follow these lines. First, load the package of the depth tools. If you do not have it, please install it first and follow those code. And when you face this and type 1, then it will insert some packages that you need. And after that, load sjplot. Then you're good. Okay, then after that, so I will use the plot model code by making this predict value of the price. So I will, inside of the code, first we should specify which model you want to use. In this case, the better model is a model 2, not model 1. So I want to use model 2. And I will make a graph of the predicted value. So specify the pred, which is abbreviation of the predict values. And I want to, for the x terms, I want to use the depth. So specify the depth here, okay? Then when you run this code, you can see the graph here. So this graph is about the predicted value of the price, which created from the model 2, and y-axis is about the price, and x-axis is about the depth, right? Okay. So as you can see, the result, the estimated result says depth has a negative effect on price, then we can see the slope is negative. It means as depth increases, the price will be decreases, and the slope is should be minus 55. So like the okay, the slope of this graph will be minus 55. We can do this, make this graph also by using different independent variable like caret. See, in this graph, the independent variable is caret, and caret has a positive effect on price. So the slope of this graph is a positive, and when the 1 unit increase of the caret should increase the price as 7,800. From this to there is kind of the 7,800. But we see the gray area here, but we cannot see any of the gray area there. Why the gray bars in this graph? What are the gray bars? So the gray bars is about the confidence interval. When you remind the confidence interval, it is the 95 or 99 areas, 99% areas that it is plausible statistically the predicted value located. But you can see the confidence interval is calculated from the standard error, and the standard error of the depth is lower than caret, but relative to the estimate coefficient, the standard error for caret is relatively much smaller than depth when we compare the coefficient. Okay, so in the depth, the confidence interval should be large because relatively large because the estimated coefficient is much smaller than the caret, but in the caret graph, the confidence interval cannot be visually observed because we have so large estimate coefficient values. And we can see also the about the cockcat. So this graph is different from the others because the value of the cockcat is only either 0 or 1. We have no value of these areas, so we just plot two dots, which is either 0 of cockcat or 1 of cockcat. Okay, and the bar plot represents confidence interval, which I talked before, and as estimate like this, the price of a diamond will be increased 1,500, something like that, when cockcat is increased from 0 to 1. So the difference from this point to that point is almost 1,500, or it is exactly 1,428.73. Okay, so this is the visualizing your estimate results, and this is really important to make your results visualized because it helps your audience to understand better about your estimation and the results and the analysis. So if I recommend you to input any visualization or graph or something like this predicted values inside of your paper, and it helps you and your audience to understand better about your research. So right now, I will go to the interaction. Let's suppose that I suspect that the effect of that to the price would be different depending on the cockcat. So I want to interact with I want to interact between depth and cockcat. So in another ways, the effect of the depth on price uh, depends on how a diamond caught it. Okay. Then when you want to include interaction term inside of your model, this is the way. Include each interaction term separately and also include the multiplication of both variable inside of the equation. So we have caret, depth, cotcat, and the multiplication between depth and cotcat. And we learn regression analysis and summarize it. So this is the estimated result. Comparing with before, like this, we can see there is some kind of the different result. First one, the estimate coefficient of the cotcat changed, which was positive, but right now becomes negative. And we have the positive coefficient of the interaction term, right? Let me see what it means. So what is important here? Okay, this one. So this model, this graph is plotting model 3 by using the interaction term. The interaction term is between depth and cotcat, and it represents when a diamond is fair cut, which is cotcat is 0, the increase of the increase in depth will follow this predict value of the price, this line, the red line. But when you have a diamond better than fair cut, then the diamond of the price of the diamond will follow this line as the depth increases. So in other words, when you can see, since cotcat is 0, okay, so in this line, the slope is only this estimate coefficient of the depth, just beta of the depth. But in this line, we should consider the marginal effect of the interaction term also together. So the slope of the blue line should be sum of this coefficient and that. So give me a sec. So this is the slide from the Professor Cox. So if you cannot follow what I explained before, I recommend you review the interaction YouTube again. And as he explained that the slope, when you include the interaction term inside of your equation, the slope will be different depending on which category an observation belong to. So in this case, just beta 3 when the man, but the slope will be changed when you have a different category, and the amount of the change is equal to the beta 4, which is the estimate coefficient of the interaction term. So it means the result means when you have a better cut diamond, then the negative effect of the depth on price is smaller than a diamond of fair cut, right? So as the depth increases, in general, the price will be decreased. But if you have a better than fair cut, the decreased amount of a price will be smaller. This is the way to interpret the interaction term. So I am running out of time, so I want to be fast. And let's introduce about the F test. So F test is about joint test or omnibus test. So by using F test, we can compare the whether our full model is better than the new model. So when you do the summary of the model, we can see the F statistic value here. It says like 79,000, but we can calculate the F statistic value by on your hand using give me a sec, this equation. So F stat calculated by this, and we subtract the R squared value of the full model from the null model and divided by M. M is the number of the restriction we have, and divided by this. This is the degree of the freedom, M minus K, and 1 minus R squared, okay? So I calculate this. K is the length of our coefficient, and N is the number of the observations, and first degree of the freedom is the number of the independent variables. In this case, model 3 has 4 independent variables, so df1 is 4, and df2 is the degree of the freedom is like this, okay? And then I calculate the F crate value using 95%. And first, the degree of the freedom is what we calculate by this, and the second one is this. And the F crate calculated as a 2.37. And I want to calculate the F statistic by using, I extract R square of my model 3 by using this code. The R square is calculated as 0.85. So, right? And using the previous equation, I calculate the F stat, and F stat calculated as a almost 79,000, which is the same result of the F statistic we have in the summary, and let's compare the calculated F stat with the value of the F crit. Then if say true, it means the F stat is greater than the F crit. So we reject the null because we have a greater value of the F stat than the F crit. And in this case, the null is all coefficient of model 3 is equal to 0. So we reject the null. It means because from the F test, we can say that at least one beta is not 0. This is we called it as an omnibus test because we pull together of all the beta and test whether all beta is equal to 0 or not. And when we have a greater value of F test than the F crit, we can say we can reject the null, and we can say at least one of the beta we have is not 0. Then we can use this F test by testing nested model testing. In this case, when we have two models and one model is have more independent variables, then we can compare those two models and whether the restriction is true or not. So we can use our previous example, the model 2. We do not have the interaction term, but model 3, we have the interaction term. So the restricted model is model 2 because by not including the interaction term, we assume that the coefficient of depth, the interaction term, cut is a 0. This is our restriction. So the null model and the restriction model is a model 2, and the full model is model 3, which do not have this assumption. Okay? So we run the F statistic, we F test by using model 2 and model 3. And first, we extract R squared of each model. Each model has this R squared. And because we have one restriction, so the first degree of the freedom is a 1. And by using it, we calculate the F crit as a 3.8 and calculate the F stat and print it. So the F stat is calculated as 47.08, and this is greater than F crit, so it is true. So we reject the null, which the null is a model 2, and the restriction of depth and the interaction, the coefficient of the interaction term is a 0. And we can say it means that the coefficient of interaction term is not 0. Okay? So it is more appropriate to use model 3 than model 2. It means the interaction term do better job to account for the variation in price of a diamond. Because of the limit of the time, I'm a little bit hesitating to finish uh, my lab. Uh, if you if you have any problem to understand what I explained before, I recommend you to review uh, the YouTubes of the Professor Cox's class, and also I recommend you run this lab by on your own. And also, if you have any question, you are welcome. I anytime. Please send me an email. Because of the time difference, I'm not quite. I cannot uh, respond you immediately, but I will do my best to respond and give uh, any feedback that you need and you deserve. So thank you all. I really enjoyed to do lab with you, and I hope that you are staying safe and healthy, and meet you next time. Thank you.